Welcome back to TeleGeography Explains the Internet. I'm your host, Greg Bryant, and my guest today is Todd Chapman, who is, as you will hear, a veteran in the fiber development space that underpins our entire industry. Todd and I had a long discussion about the ins and outs of Layer 0, as some call it, of the physical infrastructure underlying the transmission of data around the world. We talk about the process of taking a fiber project from an idea to manufacturing to lit service. And I learn a thing or two, really many, about different types of fiber and their uses and the density of fiber in deployments and the various forms that conduits can take. Really fascinating stuff to get down to that physical layer of what allows us to have an internet. So we talk about the dark fiber market and when enterprises might be interested in leasing dark fiber instead of leasing lit service. And of course, we have to talk about the impact of AI on fiber development, particularly new data center deployments. We get into who lays fiber and in what circumstances that might differ, and how regulations and laws in different countries might impact that process. Finally, we get to Todd's view on the fiber market in the next couple of years and where it might be going in a time that really promises the possibility of massive changes, not just in our industry, but really many, if not all of them, right? So, as always, if you enjoy the show, please rate us and subscribe to make sure you get episodes as soon as we have them out. And please do feel free to reach out to me and offer feedback or suggestions on the show on LinkedIn or wherever you can find me. Enjoy. Welcome to the show, Todd.
Thank you, Greg. Happy to be here.
Yeah, absolutely. So, when we first started about talking about this topic, you gave me your background, and I think in this case, it's particularly useful to hear that whole background up to why we're here talking about fiber development now. So, Todd, tell us a little bit about your history in working with getting fiber laid around the world.
Okay, great. So I started off my career working in state government and an authority that sounds very exciting.
Not the
You're
normal path to the telecom industry necessarily, but yeah.
not usually, and maybe not if you're an idealistic college student. That may not be where you picture yourself, but it was a really good place to start because I worked at a transportation authority
Mm.
that managed a very large right of way. And as part of that, they deployed an extensive fiber network in a strategic corridor in the US.
Mm-hmm.
So that afforded me the ability to work with outside plant fiber and construction and maintenance aspects of it, in addition to managing a lit network as well.
Mm-hmm.
So worked there for a few years and then eventually uh, transitioned to working for an optical networking vendor where I really cut my teeth more on deploying networks, architecting lit networks, and got a broad understanding of the fiber landscape and optical networks from enterprise through to hyperscale through to service providers.
Yeah, absolutely. And I think that, I say this pretty often on the show and in my life as well, that it's surprising that, there's a lot of people in the industry still that kind of, because they're working on certain segments of the network or the ecosystem, just kind of assume that infrastructure, right? So it's the old joke about there's a physicist and economist on a desert island, and they have one can of food, and the physicist devises this whole sort of intricate way of having a rock fall down and capture the food. And the economist says, no, you don't understand. Just assume a can opener. Right.
Yeah,
So,
exactly.
so today we're going to focus on not just assuming fiber. So, what I wanted wanted to have you on, Todd, was to take us through. I think at the start, that whole process. So fiber comes from, first a manufacturing process of fiber OEMs all the way to you have lit service that is powering what we think of as the backbone or the network or whatever. So can you maybe take us through the key steps along that journey?
Yeah, certainly. So generally, you'll have an entity that, say, wants to build a network, right? And you want to architect that to, for whatever its purpose is. So it may be a high performance long haul backbone network, or it may be, say, a municipal network that's
Hmm.
going to largely deliver internet services. And so uh, your inputs are going to vary. And so at a high level, the first thing is, okay, what's the purpose of the network? And then once you do that, you'll essentially, map out a topology and determine what sort of kind of fiber density you're looking for and what type. So if I were to use the example of, say, a high performance long haul network, I'd want a high performance network with very low loss fiber and probably high fiber counts, depending upon what my business model is. So if I was looking to lease fiber, I'd want really as much fiber and conduits as possible. So I would then look at, okay, the physical fiber itself, right, and select a vendor, right? So preeminent vendor in fiber today is Corning.
Hmm.
So I assess, okay, how much fiber do I need? So if it's a very maybe a low density uh, broadband or internet network, I might not need that much fiber. But
Hmm.
engineering a high performance long haul network, then I may want thousands of fibers in my cable.
Really? So just to put a pin in that, in the submarine cable world, you lay a submarine cable, you're talking about usually these days dozens, I think, of fiber pairs. Terrestrially, we're talking about literally thousands in a conduit.
That's correct. Yeah, because as you know, with submarine networks, your real constraint is power.
Hmm.
You have to power repeaters, throughout the cable. So
Over long spans with nothing else around, right? That's yeah,
correct,
yeah.
right. So the difference with a terrestrial network is you'll place huts, amplifier sites every 80 to 100 kilometers on a cable. All
Mm-hmm.
right, and then you also have the ability to hit pops for regenerating the signal if necessary,
Right.
which is kind of less and less important these days with the high performance and the advancements of technologies. So you don't have the same constraints in terms of power that you do on a submarine network.
Right.
So that's what allows you the ability to, uh, just have a higher density of fibers in the cable itself.
Right. Yeah, well, and I want to put a pin in something else that you said there too, which is that the first step is thinking about, okay, well, what kind of fiber development am I doing here? There's a big difference between backbone development between, say, residential where it's just a few strands, but also even at the materials level, you're saying that you might choose different kinds of fiber. Could you take us through that a little bit?
That's correct. So primarily, we'll consider single mode fiber for our discussion here. But if you go to any fiber vendor page, there are just dozens of different fiber products that they have.
Hmm.
And you want to orient this or the selection of your type of fiber to your application. So if we go back to, say, the submarine example, submarine, you'll typically want a very low loss, an ultra low loss type of fiber.
Mm.
it may have a different characteristic than a terrestrial network, where maybe loss may not be as critical, and you may
Right.
want more density. So you may want to be able to just pack more fibers in the cable itself. Um, but in addition to that, maybe not trying to go super deep in terms of types of fiber. There are
Well,
lots
I'm
of
not a
different
physicist,
characteristics.
and neither are probably most people listening. But as far as we can get without having to understand Shannon limits and stuff like that, right?
Yeah, but yeah,
Yeah.
I mean, generally, there are a few different parameters you're going to look at when you're selecting a fiber type. It's
Hmm.
loss, and it might be something called effective area, which
Hmm.
is really the cross section, the usable amount of area in a fiber. So generally, if you have a larger
Ah, okay.
effective area, you can pump more power into the fiber and therefore go further.
Right.
So you select a type of fiber itself, but then you also have to consider the cable type it's going into. And
Hmm.
so you'll also consider, okay, where am I placing the fiber? Right?
Right.
Is it aerial? Is it at the bottom of the sea where I need a shark bite proof cable, and I have
Right.
cable that has inline power? So this is really going to vary, and it's a sliding scale in terms of these different parameters and the cost, the overall cost.
Right. That is really fascinating. To be honest, again, it's one of those things where we talk about fiber all the time. I have very seldom given thought to I've known that there's different shelf lives of fiber and things like that, but to the use case of the fiber having a different actual original manufacturing. I don't know much about copper either, but I imagine that more or less copper is kind of copper for the most part, right? So I guess that for a long time I just sort of thought of, okay, you have a fiber strand, you can put more or less of them in, and you might have repeaters, but that is fascinating. All right, so take us also through, I think, a bit that you touched on here, which is acquiring the rights of way or having them and figuring out how to utilize them, getting the fiber either on poles or in the ground. What does that process look like from the manufacturing, sort of cable laying standpoint?
Yeah, great question. So generally, and let's take, say, a service provider that may be offering a building fiber network to offer
Hmm.
broadband services, and you may operate, say, in an urban and exurban area. And so generally, the first thing is to kind of build out a topology, right? So
Hmm.
do an architectural design, and then get down to the engineering level.
And you're doing this like in like a GIS kind of manner? You mean like planning, like I'm going to
Yes,
go down this street and that sort of thing? Like,
that's correct. And then
mhm.
you'll need to uh, obtain access to the rights of way, whatever they are.
Sounds like the hard
So
part to me, right there.
yeah,
Yeah.
yeah, because you're dealing with local governments, local
Hmm.
jurisdictions.
Yeah.
You have to determine, okay, where do you want to physically place? Where do you want to build the network? Right?
Right.
Is it aerial? So do you need access to poles? And this has been a major issue, kind of as of late, in terms of the regulatory conversations.
Right.
But if you're building an underground network, okay, where do you build it? Do you need to work with a utility company, say a gas company, electric company in the city, in order to get access to their rights of way, their conduits, their manholes? Because where you can get access to existing systems, it just lowers your construction costs.
Absolutely. Right. You don't want to
Yeah,
dig any novel holes if you don't have to, right? So,
yeah, exactly. So, so you go through pretty deep engineering and planning processes, permitting. There are always environmental considerations because you may be
hmm.
dealing with things such as, okay, protected wetlands, and there's a myriad of things really that can affect infrastructure builds. Um, And then, okay, once you've kind of secured all of those permits and you have a license to operate and you want to build the network, well, then you get to the construction phase of it.
Right.
So if you're going to hang cable from telephone poles, then that's one method. Um, Otherwise, if you're building, say, an underground network, there are a few different construction methods. You can do direct burial, which you probably would not see much of
Hmm.
because you don't get a lot of protection there.
Right.
Typically, you're gonna put in a conduit or a system of conduits to then pull fiber through or blow it through.
And those conduits, so everyone has seen the little orange plastic tubes, right? If you have fiber to the premises of any sort, I assume that's coming out from a larger conduit in the neighborhood. Are those made out of tougher material than orange plastic, or
Yeah. So when you're building an access network and considering your example for a broadband network, say it's
Mhm.
a new community, you put in typically a flexible conduit system, and if I use the example of my mom's neighborhood, which is was just built,
Mm-hmm.
the contractor has built a conduit system to central point on, say, her street, right
Right.
where there's a pedestal or a hut, and that's where all the flexible conduits will land.
Right.
At that point, whoever the broadband operator is will have their OLT set up there.
Hmm. Hmm.
But this is really optimized for cost, right?
Right.
If you were building, say, a long haul network or something that you just needed more protection on,
Right.
you put in a completely different conduit system. So
Gotcha.
you probably put in rigid conduit, uh, a bank of conduit. So
Hmm.
it might be 12, 16 conduits, and they might be encased in concrete, or,
Wow.
and that's
Okay.
typically in an urban environment, right?
Yeah.
But if it was not in an urban environment, then you might have that conduit system in a trench
Hmm.
and covered with dirt, and you have some warning tape on top that
Right.
provides at least an early warning of people who may be digging around it.
Here's our PSA opportunity to say, make sure you call Miss Utility before you dig. Right. Yeah.
Call
Yeah.
in a dig ticket
Yep.
always. Yeah.
Yeah. That's really interesting. So again, I had never really given this a lot of thought, but that of course it makes sense that you know a flexible conduit is much easier to bring to individual locations, whether that's a commercial location or a residential one. And then as we get deeper into, so it's very much like other built infrastructure that we're familiar with. You might go from like a gravel road to a small 2-lane road that doesn't require to a giant highway that's like got tons of infrastructure along it. That there, I had thought of it that way, but not in the thinking of like, oh, of course the backbone kind of fiber that we're laying is much, much more shielded and less prone to dig problems and things like that, I guess.
Yeah, exactly. And when you're doing these builds, you always have to adhere to the local electrical code and local
Mm-hmm.
jurisdictions and whatever those standards are. And so they're going to vary
Right.
widely.
Yeah, and then another thing that you mentioned earlier that I think would be worth following up on is that we're talking about the fiber here, but then you said every, I think, 80 to 100 kilometers there needs to be some kind of endpoint, whether that's like a full on, maybe sometimes that's all the way up to a CO or something like that. But that's a big part of this process as well, right? Is finding where you can install those. I take it.
That's correct. So if we consider a long haul network as an example,
Hmm.
um, with the advent of technology these days, you have to consider really the what folks in the industry will call layer zero, which
Right.
is the
The
photonic layer.
physical. Right. Well,
Well,
no, layer one
there
is the
it's
physical layer. Let
it's
me not confuse people. I meant like the actual. Yeah, sorry. Yeah, yeah. Sorry, go ahead.
Yeah, I mean it's a very interesting conversation about the OSI model, but
Hmm.
for when you talk to folks in the optical industry, they certainly understand the nuance of layer one, right?
Right.
There are so many layers in layer one
Hmm.
that they define a layer zero.
Got
Okay.
it.
And so for layer zero, they really refer to this as the optical, or almost consider to be an analog layer. So
Hmm.
this is where you're
Hmm.
going to have your physical fiber, and in the case of a terrestrial network, you'll have uh, amplifiers, uh, multiplexers and demultiplexers, which are
Right.
typically wavelength selective switches, and all this other gear that is used to transmit the optical signal really as far as you can get.
Right.
So in this layer zero, this is what's responsible for the amplification. In layer one, this is where you have a transponder that changes an optical signal to a digital signal, and it might be Ethernet
Right.
as an
Right.
example.
Right. Hmm. Hmm.
Um, in the olden days, you couldn't go very long relatively without having to regenerate the signal at layer one,
Right.
regenerate the go from optical to electrical back to optical.
Hmm.
So this was a really major cost for network operators. These days, with modern technology, if you have a contiguous fiber network and say it spans the entire U.S.,
Hmm.
you can essentially transmit a single signal across the U.S. without regeneration.
Really? Okay. Wow. That is another thing that's totally news to me. That is fascinating. Interesting. Now that
Yeah, because
depends, of course, on the physical geography of between those points, like that sort of thing, right? So.
that's correct. So the expensive part of operating a network is really at kind of layer one.
Hmm.
Now going back down to layer zero, where the amplifiers live, you essentially have to place these amplifiers every 80 to 100 kilometers. You can go up to say 120 for optical performance, but
Hmm.
this is what boosts the optical signal,
Right.
because inherently when you're transmitting light through a fiber cable, it has attenuation or loss.
Hmm.
So, let's say every you might have loss of say 0.18 to zero point 0.2 decibels of power per kilometer.
Okay.
And there's an optimal envelope in terms of performance for where you place these amplifier sites to boost the signal. So, really, what happens there is all of the signals get boosted at the amplifier site in aggregate.
Right.
So, the relative cost of the equipment that you put there is pretty low compared to if you needed, say, a half rack of equipment to do a full set of regenerations at, say, a POP or a data center.
Right.
That's
Right.
really the high cost component of architecting these networks.
Hmm. That is again really fascinating. I think it's so easy to forget about that part when you're just thinking about, hey, there's a backbone across the U.S. and I'm always thinking of the world in terms of 100 gig lit service price per bit. It's like, yeah. So let's move on kind of to that end. So now that we have the full spectrum of getting from here to there, right? Or stop me if we don't. But fiber demand, right? So dark fiber. I think first, like, let's just give out a clear definition of what we mean. I think almost everybody listening to the show is going to be familiar with dark fiber, but just in case, it is TeleGeography Explains the Internet. And then let's talk to Todd about like sort of that market. So there's dark fiber versus lit service. Who are the primary sort of entities that are in the dark fiber market, like looking for demand for dark fiber?
Yeah, so yeah, great topic. So dark fiber is essentially fiber that's been built by a fiber company that has not been lit. So it has not been used for their purposes to build or operate an active network.
Hmm.
So
So it's
if you use
there,
the
it's ready to
example,
go. They just haven't like put the equipment on to start sending bits over it, basically. So.
correct. So usually the business model for a lot of these long haul companies that built these large fiber networks in the 90s, and take Level 3 as an example at the
Hmm.
time, which is now present day Lumen,
Right.
is they built out a very large long haul network, uh, multiple ducts of or multiple ducts, and then they pulled fiber through those ducts. And these days, you're going to pull a fiber cable that has several thousand fiber pairs.
Hmm.
And if you're that network operator, you're only going to use a handful of those, or
Right.
maybe designate a handful of those for your current use. So if I am a wholesale, say, internet provider, I'm going to light a fiber pair with uh, optical systems vendor's equipment and connect my routers to it, and then I provide IP transit.
Right.
But
Yeah,
I have
and that's the
thousands of fiber
currency of the
pairs
realm
on.
that we're used to hearing about. So IP transit costs X per meg, or a wavelength between point A and point B. But then there's all this fiber just not being utilized, and that's where this comes in, right? So.
Exactly. So um, it's a strategic asset because the construction costs of fiber are very high.
Right.
So they and it's primarily labor, the primary labor
Hmm.
costs. So what these companies did is, okay, they built these big conduit systems. They put a little bit of fiber in there for their own use, but then they have the ability to pull much larger fiber pairs and then sell those, or I shouldn't say sell, but lease those fiber pairs to other companies that want access to that. And so that's what dark fiber is.
Hmm.
So I might lease that capacity to another network provider that does not have a network in that area. I might lease that to an enterprise that has very large demands in terms of just interconnecting their private data centers,
Hmm.
or it might be, say, a hyperscaler or a cloud company. So,
Right.
that's essentially what dark fiber is. So,
Yeah, that's really interesting because I'm a pricing analyst, so for many years we've been asked, oh, do you track prices for dark fiber leases, right? And we don't for various reasons. The biggest one being that it's a lot less of a sort of off the shelf product than say a 10 gig wave that everybody knows what the general price is. But there's an important point there, I think, in thinking about how the industry operates, that the original entity, whatever it is, a carrier, whatever else. Because we'll talk more later, I think, about how it's not just carriers that lay this fiber, right? But still owns that fiber in perpetuity for its entire life. They're just leasing it as like a piece of infrastructure. So it's kind of like maybe like a developer who builds a strip mall, and then there's like units in the strip mall, and you come in and you say, okay, well, I want to have like whatever it is, a dog washing service, right? And you have to build that space into a dog washing service, and maybe you have a long term lease on it, but then that space never truly belong to you in that sense. It's, I guess, pretty much the same for dark fiber.
yeah, that's correct. So they'll usually use contractual construct called an IRU, an indefeasible right of use, which will grant long term access of a utility to another party.
Right.
So, for some, this may be shorter in term, which would be, say, 5 years, but others have secured IRUs for uh, uh, 10, 20, 30 years.
30. Yeah. I've
So
seen I've
it
seen
really
30s for
depends
sure.
on,
Yeah.
yeah, it really depends on kind of the business model of the firm kind of engaging in that agreement.
Hmm. Yeah. Okay. So again, from my side, what's been interesting is in the last few years, like I said, for a long time, people say, oh, do you track dark fiber? Not really. In the last few years, I've seen many more people asked for that, and even had some carriers suggest that maybe they're coming up with something more like a price book that we would have seen for lit service for dark fiber, because it's becoming more common. Have you seen that in your view of the industry as well? And if so, any ideas of why dark fiber is more interesting to customers now?
Yeah, so I think that the reason you're probably getting more requests for that is that uh, the costs have come down to the point where
Mm.
it's more feasible for enterprise to procure.
Hmm. Hmm.
And we should also look at the different segments of the network. So there's an issue. So we already talked quite a bit about long haul fiber, but
Right.
there's a significant market for metro fiber.
Right.
So if I am, say, an enterprise operating in a city, I may want to interconnect, okay, my private data center to an exchange or a POP, or I might have regional uh, core locations that are strategic to my business. Right, if I'm a hospital system, I might have a
Hmm.
data center in the basement of a hospital and have this distributed throughout uh, kind of a suburban area. And so this is what is driving the demand for dark fiber.
Right.
Oftentimes, because there is a, now I would say, relatively low crossover point in terms of cost for them to procure a high capacity or a bundle of high capacity lit circuits versus light their own network with dark fiber.
Hmm.
So typically, once you get to the level of demand of, I would say right now, uh, a few hundred gigs or a few
Right.
400 gigs, then you want to consider, looking at dark fiber. So I think that's really what's kind of driving that within the metro.
So really, the economics come down to the amount of bandwidth demand that you have, but also the privateness. I mean, certainly a lit wavelength is still a private service, right? So that's that. But if you will, the dark fiber is kind of the ultimate private service in that sense, right? So yeah.
It is because and it has natural benefits to customers.
Hmm.
So one example is, okay, if you were to procure, say, a wavelength from a service provider, you generally don't have much control over the physical path that
Right.
takes in a
Right.
service provider's network. So if you have, say, a latency sensitive requirement where you want to
Hmm.
minimize the amount of infrastructure between point A and point Z, you generally don't have much control over that in a lit service.
Right.
Contrast that with procuring dark fiber. As long as there is a right of way for access for that service provider, uh, you can kind of determine your physical path.
You could go into the KMZ in this case and actually see where the fiber is, and I imagine diversity is an important part of this as well, right?
Yeah,
So
because it's very critical if you're operating a mission critical use case or operation. You may not want physical crossover points in terms of your physical fiber plant.
mhm.
Um, you may want to enter, and you typically want to enter and exit a building with diverse entrances. And especially if you're going further distances, um, it becomes more important to not have common points of failure on your
Right.
network. So you just
Right.
generally get more control over that when you have dark fiber.
Hmm.
Uh, and then another important aspect of it is, especially in the context of a metro, if the distance is short enough where I don't need amplifiers, it
Mm.
becomes much more inexpensive to operate that network because I only need equipment at the endpoints.
Because it's a LAN
So
basically instead of a network, or instead of a WAN, I should
exactly,
say. Yeah, yeah, yeah. Mm-hmm.
exactly. So with
Mm-hmm.
the advancement of especially coherent technology today in plugs,
Mm-hmm.
I can just pop a coherent plug in my routers at the endpoints,
Right.
and I generally don't need a system in the middle at all.
Right. So I don't need like a network service. It's essentially like, an old school idea of I'm connecting this Cat 6 cable to this other computer, basically, right? So yeah.
Correct. And you can
Yeah.
also have just generally passive equipment at the endpoints,
Mm-hmm.
where
Mm-hmm.
you get a good amount of get a good amount of density, um, but without much operational complexity.
Right.
So this is really exciting for um, folks that operate or have demand for metro networks.
Mm-hmm. Mm-hmm. Yeah, excellent. Very interesting. All right, so Todd, it's 2025, and I'm basically contractually obligated to talk about AI now. so, so I have to touch on this a little bit before we wrap up, which is just that. So one of the key things about AI for the telecom business is, of course, it generates a lot of bandwidth demand, right? So, whatever these AI systems are, one of the hallmarks of them is that it's huge amounts of computing, usually remotely from the user, right? So if you use ChatGPT or Gemini or anything like that, it is not local to your machine. I think most AI tools are going to be this way, are this way. So what are we doing? We're hearing in the news, even just this week, about sort of initiatives at all kinds of levels to facilitate the building of new data centers. We want to build new data centers near what AI needs, which is power, right? It has always been the case in our industry. It feels to me that the data center parameters are cost of real estate, the availability of affordable power, and they forget the fiber part. Right? So talk about getting fiber. So let's take a concrete example. Maybe I'm sure lots of folks have heard about like Eastern Washington State, right? A place where it is beneficial to build data centers for various reasons that we can leave to a data center conversation, but is not beneficial from a fiber standpoint, from what I can tell, right? So.
Yeah, that's correct. Yeah. So the AI, the, the dynamics of the AI driven demand are uh, just revolutionary in terms of the impact on the network and infrastructure generally.
Mm-hmm.
So, as you said, large, generally hyperscalers are placing these data centers where they can get inexpensive power.
Well, and that's why I mentioned
Or,
Eastern Washington specifically, as
right,
you might. If anyone isn't picking up what I'm throwing down, that's where Azure is located, right, or Microsoft. So, yeah, yeah.
right. So, and oftentimes it's because, okay, this has been incentivized by,
Mm-hmm.
local governments or whatever it is. So, typically, in terms of the priority, fiber is, I'm not going to say low priority, but it's not the top of the list now for AI.
Right.
So what these hyperscalers are looking to do, and this stuff is public, you'll hear, and I'm going to use Lumen again as an example.
Mm-hmm.
You'll hear Lumen CEO Kate Johnson talk about this stuff. Um, they're signing strategic deals to help the hyperscalers build their networks out,
Mm-hmm.
specifically for AI.
Right.
So, what will this typically look like? Uh, because AI is very sensitive to latency and interconnecting GPUs. Uh, you typically want a minimal amount of equipment uh, in the middle. So this is leading to, and I think it kind of aligns to our metro discussion. It's a very similar type of architecture where you essentially want just a direct connection in terms of the fiber
Right.
uh, between the endpoints. So with the scale they're looking at, where you're having hundreds of thousands of GPUs in these AI data centers, they need to be interconnected with the fiber, and they need to be interconnected with lots of fiber.
Mm-hmm.
So we're talking on the order of thousands of fiber pairs. So it's a strategic build out it's driving a strategic build out that we just haven't seen historically.
Right.
And so typically what that's going to look like is that's going to look like a hyperscaler going to a infrastructure provider like Lumen and looking for uh, massive amounts of conduit
Right.
and the maximum amount of fiber that they can put in the conduit to interconnect their new AI data centers to maybe critical POPs critical exchanges or other parts of their private infrastructure.
Mm-hmm. Yeah, well, and I think an important point there too is that it's not just this massive amount of demand, but also that, as you said earlier, that a lot of these AI tools require a certain latency to be as efficient as possible. So it's also about making those builds geographically, physically as close as possible to whatever end users there might be, right? So.
Yeah, that's correct. And another interesting wrinkle to this, if we look at maybe that region, um, that region is not fiber dense.
Mm-hmm.
So you're typically looking at networks that were built long ago by the likes of, say, Sprint, where uh, it's going to drive a significant build to, say, connect Eastern Washington to Chicago
Right,
or other
right.
strategic geographies. And
Mm-hmm.
so this is really what's driving these large strategic agreements, because the network operators need the capital investment and
Mm-hmm.
the assurance of the cloud providers in order to drive those builds.
Right, right, absolutely. Yeah, well, and there's a bunch of implications. So it's obviously some easy implications. It's good for Corning, right? You know, what I mean? It's or all the OEMs. There's a lot of OEMs involved in this whole process, right? You know, but it's also interesting from the standpoint of thinking about the fiber supply business. So you gave the example of Lumen, maybe laying thousands of fiber pairs. They're going to offer their own lit service. Over some of this, they're going to sell some of that dark fiber. Presumably there's going to be other fiber developers, right, who also see this opportunity. I think anytime there's a backbone built, that's where we see the most competition for this sort of thing. So let's talk to wrap things up, Todd, about the fiber supply market. We've kind of gone through the physical development, the demand, hit the supply side. So you brought up Lumen. Carriers, as what we think of as the ILECs or the PTTs of the world, are not the only folks who lay fiber, right? This is an activity that all kinds of different entities might do, right?
That's correct. Yeah, and you'll see more variation in metro fiber than long
Right,
haul.
right. Backbone really
Yeah,
is the business of a Lumen or whatever, but yeah. Mm-hmm.
that's correct. Yeah, in terms of metro fiber, uh, and a lot of this is driven by BEAD funding and obviously a strategic investment on the government's part in terms of
Mm-hmm.
helping operators or just incentivizing new companies to build out these networks.
Right.
But you'll have, say, municipal governments as an example,
Mm-hmm.
build shared access networks,
Mm-hmm.
or you might have utility companies,
Mm.
because oftentimes a power company, a water company, a gas company already has this right of way
Right.
where it's very easy for them to add fiber infrastructure to that. So they might
Not
do
just the
that.
rights of way themselves, but also already having physical infrastructure, conduits, manholes, things like that. It was part of that, right? So.
Well, that's correct. Yeah, because I mean they're already going to have these networks anyway.
Mm-hmm.
Oftentimes, oftentimes on assets that they own. So incrementally, there's not a heavy lift for them to then go construct a network for public use or wholesale use or whatever
Right.
the use case may be. So we're
Mm-hmm.
seeing significant proliferation of municipal networks for broadband and co-ops and things of this nature.
And that makes a lot of sense from the conversation that we had earlier in terms of just the economics of putting thousands of fiber pairs in a backbone. Very different than getting a single strand to a house, right, or even a strip mall or something like that, right? So I think municipal governments might have an interest in a public-private partnership where things wouldn't otherwise make a lot of economic sense, maybe.
That's correct. Absolutely. Yeah, because
Yeah.
they're looking at getting just building out networks to rural areas, passing more homes and businesses, because we're at the limits of what we can do with coax and electrical. So
Hmm.
fiber is certainly the way forward.
Yeah. And we did have this infrastructure bill in the U.S. that promises a lot of money towards broadband development. Have you seen that spur kind of new projects over the past what has it been, a couple of years maybe since that came out?
Yeah, certainly it's been kind of relatively slow going because a lot of the requirements can be
Yeah.
onerous. right? But
Hmm.
we're seeing a lot of those funds start to unlock. I mean, the federal government, I think, is seeing that it's become a bit of a problem in terms of the velocity for which these networks can be designed and built. So I know
Hmm.
that's one thing certainly that these recipients of these funds are kind of leaning on the government to do. But yeah,
Well, it's
certainly,
always the way it is. Right?
right.
Yeah. I remember the Australian National Broadband Network. Followed that for a long time. Really, the last decade, and it took way longer. It was much more difficult, and it's sort of a law about any human project is that it's going to be longer and more expensive than you think. But from what I can tell, the Australian market really has benefited greatly from having undertaken that big project. So, hopefully we get some of that here.
Yeah, yeah, exactly.
Excellent. All right, so Todd, we are running out of time, but I always have to ask a question like this to wrap things up. In this case, I want to look maybe towards the near term because obviously, as we've already discussed, AI and its impact and these new data centers. But what do you see over the next couple of years in terms of the fiber market? We've talked a lot about the U.S., but feel free to think about the world as well.
Yeah, so great question. I think AI certainly is going to drive kind of these new use cases and new business models, which we haven't seen emerge yet,
Hmm.
where we've been doing a lot of talking about the massive demands for training, but as you get to AI inferencing and these things needing to be done closer to the user, what
Mm-hmm.
is the impact that that has on fiber networks? I
Yeah.
think ultimately enterprise demand is just going to continue to grow, especially for access networks
Hmm.
uh,
Agreed. Yeah.
globally, right? But another interesting wrinkle to this too is that the U.S. fiber market is very different than the rest of the world,
Mm.
where regulatory differences, as an example, may not afford, say, a hyperscaler the ability to hold title and operate a network in a particular geography. So
Right.
they're 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 relegated to leveraging the approved service providers to operate these massive scale networks
Hmm.
that they wouldn't in the U.S. So um, as I think AI grows, it's going to have a really certainly an outsized impact, but it's going to be disparate in different parts of the globe because of the regulatory controls.
Right.
So I can't really predict what
Hmm.
shape that's going to
Hmm.
take, but certainly I think there will be a disparity.
Yeah. No, no, that makes a lot of sense, and it's always, I think, interesting to see how those differences in regulatory, but also just the existing physical infrastructure can impact something that again even people in the industry are thinking of as this flat world of okay, what's interesting is what's happening above layer one, two, and three, really practically, even right, you know what I mean? But that it's so crucial to this to this actual physical infrastructure. Something I like to say often on the show that is there's one takeaway that I hope that again lay people particularly, but even sometimes people in the industry is that 99% of everything that we do digitally is on wires, and it's always going to be that way, right? You know what I mean? And those wires have you've given us, I think, a great review of just what it takes to make sure that those wires are everywhere they need to be and functioning properly. So
Yep, exactly.
yeah, well, yeah. So thank you so much for that. I learned a lot. If folks want to keep up with you, Todd, in any way, where can they find you?
Yeah, if they want to keep up with me, I am on LinkedIn,
Hmm.
Todd Chapman, and would love to hear from folks.
Excellent. Yeah, yeah. This is one where I would like to hear some feedback because I think there's all these little niches and issues in this part of the industry that don't get talked about enough. So I find this really fascinating. Awesome. All right. Thanks so much, Todd. I'm really glad that you brought this topic to my attention and offered your expertise here. So thank you.
You're welcome, Greg. I'm very happy to be here.
All right. Cheers. Thanks for listening. TeleGeography Explains the Internet comes from the experts here at TeleGeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.